Okay, so we are looking at the question called kth smallest product of two sorted arrays. The problem statement is pretty concise. It says that we have given two zero index integer sorted arrays nums1 and nums2 and an integer k. We need to find the kth smallest product of this particular combination. One element will be from nums1 and one element will be from nums2. And yeah, the constraints that are given are the total number of elements in each of this array can be 10 raised to the power 4, and the value will be 10 raised to the power 5, from minus 10 raised to the power 5 to plus 10 raised to the power 5, and this is the length. Right, so let's again understand the question. The question says that we are given two arrays, nums1, nums2. All right, and we need to select an element from here and an element from here, and basically all of the possible elements, like all elements from here, and then for each of the elements, all elements from here. Then we need to find, or we need to create a vector or an array which will contain all of those products, right? Then we need to sort this array, basically sort all of the products in ascending order and find the kth smallest product. So within the question we have the brute force solution. All right, we have the brute force solution within the question. Okay, now but obviously this will not be accepted. Why? Because we have first n square to, like, for these two for loops to select all of these elements, and then this vector will contain n square elements. All right, and then sorting this will take n square log of n square, right? And n square is 10 raised to the power 4 square, so n is 10 raised to the power 4 log of 10 raised to the power 4 square. This is 10 raised to the power 8 into log 10 raised to the power 8. This is close to 8 into 10 raised to the power 8. 8 is pretty close to 10, so this is approximately 10 raised to the power 9, so that definitely this will not be accepted. Okay, so now let's move towards the optimized approach. See, we need to find the kth smallest product, right? And product will be a into b. A is some number from nums1 and b is some number from nums2. Okay, if we break this problem down into a smaller subparts, let's say we have a number x. We want to find how many products less than x are possible using this combination. Can we do this? How many products less than x are possible using this combination? Let's say using this combination we get products p1, p2, p3, p4, p5, p6, and so on. Let's say case 4. So p4 is our answer. Now I select a random value x. It somewhere lies here, p7, right? And somehow we are able to find out that how many products are possible which are less than this x. So the answer is 7. So now we know, okay, so 7 possible products are there which are less than x, but we need to find the fourth smallest possible, fourth smallest product. So we need to reduce this value of x, right? Okay, let's move it to 4. So how many smaller or equal products than 4 are possible? 1, 2, 3, 4. Okay, 4 products are possible which are smaller or equal to 4, which means this is the answer, right? So can we see a binary search here? Definitely we can see, right? What condition of binary search are we able to see here? So we have some x, right? We want to find the kth smallest product. Okay, we need to find the kth smallest product. We will find out, let's say, some count. This count value denotes number of products less than or equal to x. Okay, less than or equal to x. If this count is greater than or equals to k, which means our answer is less than x, or if this count is less than k, which means less than k products are there which are smaller than x, which means kth smallest is greater than x. So in this case we need to go ahead, and x can never be our answer. But for greater than equals to k, this can be our answer and the answer can be smaller. Okay, so let's write the code till now, and how are we able to arrive at this thing we'll see later. So let's start with the code till now. So we can see that we are basically finding some x, and we are figuring out whether this x can be our answer or not, right? So this technique is called, this is a very popular technique, this is called binary searching on answers, right? Where answers will be from some range low to high. High will be, so we can see the constraint is maximum 10 raised to the power 5, so square of this will be 10 raised to the power 10, 1 8 10, and let's add 5 more for just for the segmentation security, and leg long low will be minus 1 into this high value, right? And we are finding some x which is equals to low plus high minus low by 2. Okay, and let's say for now our answer is high. All right, so we are going from low to high. Okay, so let's recalculate our x. This will be low, let's rewrite this down. This will be low plus high minus low by 2. Okay, now we need to see if this x is possible or not. When will this be possible? When will this be possible? Let's revise. This will only be possible if we have products, we have more than or equal to k products less than or equal to x. Does this make sense? Right? Less than or equal to x. Should I repeat this again? Let me repeat this once more. I am saying that we have some x. This answer is only possible when, let's say, all these are the products. If let's say this is k and this is currently x, if the previous elements including this is greater than or equals to k. Why? Because then only the answer will lie in this range. Otherwise answer will be somewhere here and it will not be in this range. We need to increase our low. Okay, so we'll count the number of products. Less than equals to x should be more than or equal to k, right? So let's call this possible, and let's say for now this is not possible. Okay, so but if somehow it is possible, then this answer is possible. Okay, and we'll search for lower answers. Okay, else this answer is not possible and we need to go higher. So else if mm, no, else low equals to x plus 1, right? And we can return the answer. Now we need to populate this possible variable. Let's talk about this. How will be how will we be figuring out how many products are less than or equals to this x? This is the now real question. So what we can do here is we have nums1, we have nums2. These are the arrays. Okay, we have some a1, a2, a3 and so on, b1, b2, b3 and so on. We need to select some element from here and some element from here. Okay, now let's say we select a1. So a1 into some value is equals to x. Okay, now we need to find all of the values here in b such that the product is either equals to x or less than this. Okay, so let's call this threshold. Let's call this value threshold, and we need to find in this array values less, such that like less than it, if let's say this is 2 and this is 10, the threshold will be 5. So we need to find all of the values less than or equals to 5, right? So that product never becomes greater than 10. But the catch is, what if it is minus 2? Now the threshold is minus 5. So should we find values less than threshold? Because less than threshold will be minus 6, and minus 2 into minus 6 will be plus 12. This will become greater than x. All right. Is this making sense? So what I'm saying is, let's say a into threshold equals to x. If a is greater than it's greater than 0, then we need to find values less than threshold, right? Because 2 into 4 is 8, 2 into minus 5 is minus 10. All of this is less than target. But if a is less than 0, then we cannot find values less than threshold, because multiplying it with the negative value will, the final product will be greater than x. So here a into threshold value should be greater than or equal to threshold. Is this making sense? Is this making any sense? Now, what is the third condition? The third condition is a is equals to 0. So if let's say now we have some target x, a into threshold equals to x. So this is you need to listen this carefully. If a into threshold is equals to x and a is 0, which means threshold will be x upon 0. Does this make any sense? I don't think so, right? So let's look at the graph. So a upon, so let's say this is the graph for y equals to a upon x. This is x. So right, so at x equals to a, right, this will become 1, y will become 1, and x equals to minus a, y will become minus 1, and at 0, at x equals to infinity, the a will become infinity, the y will become infinity. This goes something like this, and this goes something like this. Okay, what is this y? So now let's come here, threshold, right? So this y is threshold. So for x equals to 0, this is either plus infinity or minus infinity. Okay, plus infinity is when this is positive, this value above is positive, and otherwise this is minus infinity. So if threshold is plus infinity, which means any number can be selected, because all of the numbers in nums2 will be all of the numbers in nums2 will be less than infinity, right? And so basically all of the values will be less than infinity, so all of them will satisfy. Otherwise they will not. So in case of a equals to 0, if your x is greater than 0, then all of the elements in nums2 will satisfy, and if x is less than 0, then none will satisfy. Is this making sense? Is this making sense? So we found threshold when a is greater than 0, threshold when a is less than 0, and when a is equals to 0. Let's talk more about when a is greater than 0, right? So let's say a is 2 into threshold equals to 5. Threshold will be 2.5. We need to find all the elements which are less than or equals to 5, which means they should be less than or equals to 2.5 threshold, right? So in nums2 we need to find all of the elements less than or equals to 2.5, but 2.5 will not be there because this is an integer array. So either there will be 2 or there will be 3. When we'll multiply 3 with 2, we'll get 6. So we don't want this. We only want elements which are less than or equals to 2. Okay. How will we calculate this? How will we be calculating this? So the floor of 2.5 will be 2. We want all the elements which are less than or equals to 2. Okay. All the elements which are less than or equals to 2. So can we find the first number which is greater than 2? Let's say it is 4 in this array. It may be 3, it may be 5, right? Any number which is greater than 2, and we pick all of the numbers which are less than that. So if we are able to find this index, we will be able to find the count of all of these numbers. This will be done using upper bound, right? What is upper bound? Upper bound is like, for upper bound for y in nums is the first number which is greater than y. First number which is greater than y. Let's say 5. So the first number which is greater than 5, let's say it's 7. 1, 3, 4, 5, 5, 7. So this is the upper bound. So we'll find all of these elements 1, 2, 3, 4, 5. There are 5 elements which are less than threshold. So we can pick all of these 5 elements for our product, right? I think this should make sense. Let's say if it is something like this, 2 into threshold equals to 8. So now threshold is 4. This is this is not in decimal. So again we can find upper bound. Let's say it is 5, and we'll take all of the elements which are less than 5. I think this makes sense. So this is how we'll be calculating the threshold, right? What if a is less than 0? Let's talk about this. Let's say it is minus 2 into threshold equals to 5. Threshold will be minus 2.5. Okay. Here the floor will be minus 3 and seal will be minus 2. Now we want all of the elements which are greater than or equals to minus 2.5, which means a minus 2.5 is not possible. So which means we want greater than or equals to minus 2. Okay. So we take seal of minus 2.5. This will become minus 2. And we'll take all of the elements starting from here. How can we do this? Lower bound, right? In a sorted array, we want to find the first element which is greater than or equals to minus 2. We do lower bound and take all of the elements which are on the right. Now let's see, why can't we do upper bound? Now let's see why can't we do upper bound. Let's say what if we take minus 3 and we'll do upper bound, and we'll again get minus 2 or greater than that. But no, let's say we have minus 2 into threshold equals to 8, so threshold becomes minus 4. Now what we'll do, now what will happen if we do upper bound? We'll get minus 3 and we'll take from here, though we also want minus 4, right? But if we do lower bound, then we'll get all of the elements including minus 4. So what is our strategy? We'll take seal and then we'll do lower bound. Yeah, I think this is very very intuitive. Should we revise? For calculating thresholds and products less than excuse me for my handwriting, less than or equals to x, what we'll do, if the element we are selecting is greater than 0, the threshold will be floor of x by a. And then what we'll do, we'll take upper bound, which means just element just greater than this, and we'll take all of the element less than that, because for a greater than 0, we want the number, like we want the second number as low as possible, right? So that it doesn't exceeds x. For a less than 0, threshold will be seal of x by a, and we'll do lower bound. See this video again if you are getting confused, right? And if a equals to 0, we saw this is how the graph looks like. We'll only select this one. So if x greater than equals to 0, then all of the elements will be added. N2 is the number of elements in the second array. If this, then no element is less than minus infinity, so no element will be added. Let's try to code this. Let's try to now code this. Okay, so let's say we have count equals to 0. This is the number of products less than or equal to what x. Okay, uh, we will want n1 equals to nums1 dot size and n2 equals to nums2 dot size. Okay, let's iterate over the first array. Okay, for int I equals to 0, tell I n1 I plus plus. um, so num1, let's call it a, will be nums1 I if a is greater than 0, else if a is less than 0, else if uh, mm, 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 x is greater than equals to 0, right? Count here will be added by n2. Here we'll first calculate threshold. This will be equals to, when it is greater than 0, it will be equals to floor of float x by a. Why float? Because this is a because this is integer division, so for decimal division we need to add float and the floor, and then after that we'll get number equals to, we'll do an upper bound of nums2 dot begin, nums2 dot end, and then we'll pass threshold. And to get the index, what we do is we subtract it with nums dot begin. Okay, and all of the numbers will be added to our answer, because it is starting from 0 to 1. Like let's say it is starting 0 1 2 3 4 and 5, and let's say our upper bound is at 5. Like this is the index that is returned. Then all of these elements will be selected. How many of these elements are there? 5. So it is equals to the index that is there, right? So we'll get at num we'll get 5. So we'll add 5 because there are 5 elements behind it. Okay, I think this makes sense. Now let's look at the threshold for the second one. Long threshold will be ceil of float x by a. Int number will be lower bound nums 1 dot begin. I'm sorry, nums 2, nums 2 dot end, threshold minus nums 2 dot begin. Um, Here also I should have written 2. Now let's say 0, 1, 2, 3, 4, 5. Let's say we got 3. What we want, these two, total these 3. How many elements are there? 6, and we subtract it with 3, we get 3. 3, 4, 5, right? So count will be plus equals to n2 minus number. Okay, yeah. So if at any point count becomes greater than or equals to k, right, which means the number of subsets, no, the number of products less than equals to x becomes greater than equals to k, then the possible becomes true. So actually float has a little less precision, so we will want to have double, and because the x can be a very large value, and so using float will not give us the correct answer, it will have precision issues. So yeah, that's why we'll use double, and now this should be submitted. Let's try to submit this. Yes, this is correct. So yeah, this was the question for today, and I hope it is clear.